Hello everyone, I created this short video to give you an example of how the one sample t-test is run. So this is, it focuses just on the one sample t-test. So I load in my modules and I use this data frame, wages data frame that I got off Kaggle. And then I take a look at the data and see that there are some 6 columns, and then I see the size of my data set. It's 1,300 plus rows, and I do some descriptive statistics on the data, and I see it's got ages and height and education level and age. And so because I think earnings is not normally distributed, the standard deviation is almost as large as the mean. So we'll use height as our variable. So the research question is the age measure in this sample different from that of the US population? And I make some assumptions about what the average age in the US population is. I set it at 50. And so my null hypothesis states that the mean age of the sample is the same as the mean age of the population. The alternative hypothesis says that the average age is less. So this is going to be a left-tailed experiment. So now we set our, let's make sure we run that, and now we have our alpha. And so now we can actually perform our one sample t-test. We can actually do it, we can actually put the whole series into this and get the sample, the results of this one sample t-test. So if we did that and we saw we can get the p-value, sorry, the T-statistics and the p-value. And we see that this p-value is extremely small. So we know that, we are way into this reject region out here. So we would definitely reject our null hypothesis. Now, if we wanted to do it the long way, then we would get the mean, and we get the standard deviation and length, and then we would use that to get our t-stat value. And we see that our t-stat is minus 10, right? And if we were to evaluate that based on the t-critical, so we see that our t-critical here is minus 1.645. So if we look here, this is what, this is, simulation of the T distribution. It's not quite the one that we have because the degrees of freedom is much larger. But we see that this would be where a T critical of minus 1.645 would lie. And our value is somewhere out here, minus 10. So it's very much in the extreme region, in the rejection region of very low probability. And so we would reject our null hypothesis. So we conducted this left-tailed test. We used our alpha as 0.005, and we got our T alpha as minus 1.65, but our T-stat was minus 10, so definitely rejected. So we followed the steps, we stated our hypothesis, we got our alpha, and then we had our one sample t-test from which we got the t-critical, we got the p-value, and we compared that to the alpha in our that we had established. And we also compared the critical value to our T critical. We compared the T stat to the critical value. And in both cases, we saw that it was indeed extreme value. And so we must reject our null hypothesis.